Hi everyone, it's Mrs. Suter, and today we're going to be talking about sound energy. And so we're going to do some labs here on my table. We're going to have a challenge for you to do something with sound, and we're going to make some comparisons between sound, light, and water. So think about what do those things have in common? All right, so let's get started. I'm going to share my screen with you, and we're going to be talking about sound to begin with. And you're going to see a picture of Calvin, and he's going sound. Okay, so this is Calvin, and he's screaming, and you see sound. So our first question for today is, well, what is sound? So I want you to think about for a minute, what is sound? How would you describe it? Okay, well, you might describe it as noise. Or maybe you might describe it as music. Or maybe you could describe it like birds chirping is sound, right? So is a car horn. And there's sound right now. There's sound of my voice. So talking is sound, right? So there's lots of different kinds of sound. But when we think about what is sound in particular, we need to start thinking about the science behind sound. So what causes sound? That's our question now. What causes that sound? We talked about music. Well, what causes music? Well, we have like strumming on a guitar is music. Things that are sound and what cause sound. We come back to one big question. There's one thing that all of these have in common. So let's put here talking. And we have, what was it, hitting guitar or hitting drums? Hitting a drum. Okay. These were all things that would cause the sound that we talked about earlier. Okay. But let's go in talking more about really what do all of these things have in common? Well, all of these things have vibration in common. And so you might say to yourself, what is a vibration? Well, a vibration is a very fast back and forth motion. Now we can show you vibration very easily by using a rubber band. So I have a large rubber band, and if I want to show you vibration, I'm just going to pull my rubber band out, and I'm going to kind of flick one of the strings. Whoop, maybe I better hold it like this. Can you see the vibration? It's a very quick back and forth motion. Now, as this is vibrating, can you hear sound? Yeah, so sound is really caused by vibration. Now, there's lots of vibration. When I hit the drums, I get vibration. When I strum my guitar, there's a vibration, okay? When I talk, there's a vibration. Now, you may not know where the vibration is, but we're going to find out. Take your two fingers, put them up here to your throat, and then I want you to hum or talk, say your name. When you talk or hum, you can feel vibration. And that's because, excuse me, back here you have vocal cords, and these vocal cords are vibrating because of the air in your lungs being pushed up, vibrating the vocal cords, which then makes the sound that you're hearing. Okay, now that sound energy also vibrates the sound particles around it, and then that sound, the vibration, travels in the air particles and they reach your ear so that you can hear them. Now inside your ear you have these really tiny little bones, and those bones will then vibrate, move, and they transfer that energy to your brain so that you get the communication, you understand what's happening. Now sometimes people say, well, I don't see the vibrations. Well, most of the time we don't see vibrations, but I can feel them here. I can see them with a rubber band. But another way that I can see vibrations is with a very simple little experiment or little investigation. I just have a kitchen bowl, and I put some saran wrap over it, and I just used a rubber band to hold my saran wrap on there. Okay, try to get some of my wrinkles out. Now, I'm going to be showing you how the vibration is going to travel, okay? So I'm just using some cake sprinkles, and I'm going to sprinkle them on my top of my saran wrap, okay? Now, I'm going to make vibrations on the table. Now, the vibrations make the little cake sprinkles move. The harder the vibration, the more my sprinkles move, the less the vibration, the less they move. Now, you also heard sound because the vibration also causes sound. Now, the vibrations traveled through the table, through the glass bowl, through the saran wrap to make the jimmies jump around. Okay. Now, another neat thing just to do this kind of a lab and then put the bowl on top of a speaker and turn the speaker up loud, and then you can see the little cake jimmies dancing around. Okay, so just a nice little investigation there for you to look at home and try at home. All right, so I'm going to share my screen with you again, and you can see that we're going to do another simulation, and this simulation is on the computer. Okay, here's the one we were just talking about, the rubber band. You can see that the rubber band pushes the air, and that makes that vibration travel through the airwaves. Okay, when the vibration stops, the sound stops. Now, this is the little experiment I just showed you with watching the little cake sprinkles or cookie sprinkles dance, and this is something that you can do at home. All right, so now let's go in here and let's really start looking at sound. Whoop. And let's look at how sound travels. And this is a simulation from a website called PhET Simulations. And what we're going to do is we're going to look at vibrations and the sound. Okay, now this one actually does 3 different types of waves: water waves, sound waves, which right here is the speaker, and light waves, which are here. Okay, you're going to see these 2 words, frequency and amplitude. Now, frequency is how close, how many waves appear in a certain distance. Like if there were 1 wave in a centimeter, or 2 or 3 or 4. The more waves in the centimeter, the higher the frequency, the more energy that you're getting. Okay, amplitude is how tall the waves get. Okay, and so we can take a look at these and we can adjust them on here. Frequency would be your pitch, how high or low the sound is, and amplitude would be like your volume. Okay, so I'm going to put on the speaker right now, and I want to see the graph of the wave, and I want to also hear the tone being played. So I'm going to reshare to make sure that you're going to hear my sound. Okay, here we go. And I'm going to just show the waves right now. Okay, so when I hit the go button, you can hear the sound. You can see the waves traveling through the air molecules, and you can see the wave here. Now you can see the amplitude is how high the wave is going down. That is our amplitude. Our frequency is how many waves in this centimeter. So right now I have just 1 in the centimeter. Now, if I want to make it so that there's more than that, I'm going to up the frequency, listen to the tone, and see how it changes. Now you can see I have 2.5 waves in the same distance. So I've increased the frequency, which has increased the pitch of the sound. You can see that I get 4 waves in this distance. Okay, now I'm going to get less by turning the frequency down. That's where we started. Now you can see that I have less waves in that amount of space because my frequency is low. Okay, let's put it back up here to the middle. Now this time let's play around with the amplitude. Now the amplitude is like your volume. Okay, so right here it's in the middle. You can see that my wave is going up and down just to the height of the first dotted gray lines. Now, as I increase the amplitude, watch how that wave gets higher volume gets really, really low, just like a whisper. Okay, so I'm going to turn it back up to the middle of the ground. And I'm also going to show you the particles. Okay, so I'm going to take the wave and I'm going to show you the particles. So here's the particles. Notice as the sound speaker moves, the particles are bouncing back and forth, that vibration. Okay? Now as I increase the frequency, notice that they're moving faster. Okay, bouncing in and out. This would be like the air molecules. Okay, now see change in the particles, how they've changed, the waves have changed. Okay, now bring that back up. Now we're going to do the amplitude. Here you can see, wow, more energy. Notice how they're moving big spaces. Okay, now I'm moving down low. Now they're not moving, they're getting closer together and the waves aren't as distinct. Okay, let's turn it back up. Now you can see those waves forming again, bouncing those molecules around. Now I can actually show both waves and the particles, and you can definitely see the waves happening. And then I can also bring the graph back on and I can take a look. So this gives me a good idea of sound waves travel. Now, let's say I want to do water waves. Okay. Now this one you're not going to hear the tone because there's no sound to it, but I can start it and I can, increasing the frequency would be increasing how often the drip happens, and amplitude would be how big the drop of water is. So if I increase the frequency, it's dripping more regularly, my waves get closer together. Okay, now I'm going to put it back down the middle. If I go down here to it's very, very seldom dripping, you can see my waves get further apart. Now, let's put it back in the middle. Amplitude. This is how big the drop is. So I can make it so it's just a tiny little drop. Notice that the waves have a lot less energy, not as high of a wavelength or of an amplitude. Now, when I make the drop bigger, you can see that the amplitude, the wave is getting taller, until I get big drops of water, which makes my amplitude or the height of the wave much bigger yet. Okay, and you can see that both the sound and the water are slower moving. Okay, but let's take a look at light. Okay, I can do the same thing with the amplitude and frequency of light. So this is going to change the color, and this is going to change the amplitude of the brightness. Okay, so I'm going to turn it on. And right now you see that I have kind of a teal colored light. Look at how fast, look at how much faster the wavelengths are. Now look at blue, go to purple. Look at how fast this one is. Look at the frequency, how much faster. We see that purple light travels very, very fast, or indigo. Okay. Now if I go down here to the red, almost black, you get a smaller wavelength, because light, different colors of light travel and have different amounts of energy. So you can see as I go up the spectrum, my wavelengths and my amplitudes increase. Okay, and so you can play around even here with your brightness and the colors and take a look at the waves. So, and you can adjust it right here. Okay, so back to the sound. Up there, I'm going to go turn it off. And now you can play around with that anytime you want. It's called wave interference, and it is on PhET simulations. All right. Now, what we're going to do today is we're going to build a rubber band guitar. So we're going to use the information that we learned about vibrations to build our rubber band guitar. Now I'm going to show you with mine. I have a tissue box. Now my tissue box is not the long one. It's the square one, and it works just as well. You could also use an oatmeal container or a Pringles can. So what I'm going to do is I'm going to take my rubber bands and stretch it over top of the hole in my tissue box. And I'm going to use some pencils on both ends to kind of raise up that a rubber band off the box. And now, you notice that the pitches are different. If I move in the pencils, the sound changes. Move them out. Do you hear the difference in the sound based on how far out my pencils are, where the rubber bands are located? And also, if I use different sizes of rubber bands, it would make a difference. Okay, so we could create our own musical instrument. So let's say I wanted to put another rubber band on. Now all of my rubber bands are the same size because that's what I had. So I'm going to put another one on, kind of here, and move them around. Okay, move my pencils, and I'm going to use another pencil to strum it. I can pluck it. You can hear the difference based on how tight they are wrapped. And I can move the pencils out further. I can even put them out here on the edges. Gives me a much different sound than when I have them up here. And so I can create my own musical instrument right here. Now, you can hear the sound better because of the air. It's the vibrations are moving the air in here. It's bouncing back out, and this is making the sound louder. Now, your challenge today is to build your own musical instrument. So, one idea that we could use is to take the musical instrument we just built there, but kind of add on to it a little bit. Could you change your guitar to make it actually look like a real guitar? And you can see they have a pencil here and different size rubber bands, and the way that you change where the position is of the rubber bands and the pencil, you can make different sounds. So can you make a real guitar? Now, if you want to make one like in the movie Coco, you can see that there is directions online for how to create your own Coco guitar. So if you're interested in completing that challenge of actually creating your own musical instrument, I would love to see what you have created when you're finished. So please be sure to share. Have fun building your musical instrument. I hope you learned a lot about sound waves, and how they're related to water waves and light waves. Till next time, keep thinking.